Chapter 4, Section 2 is about writing equations in point-slope form. Previously in Section 1, we talked about slope-intercept form. And the name itself, slope-intercept form, and then today, point-slope form, kind of just tells you like what information you're either given or that you're maybe trying to find in order for you to graph the line or write the equation of the line. So before this, when you did slope-intercept form, you were using the slope, and you were using the y-intercept, which would be a point on the y-axis. Now, in this section, when we talk about point-slope form, you're still going to be using the slope, but you're also going to be given a point, which may not be on the y-axis anymore. So we're going to go over exactly what does point-slope look like, and then how do you write an equation in point-slope form, given a couple of variety of circumstances or situations, and then how do you graph these types of lines as well. Now, how point-slope form was kind of created is based off of the slope equation, which we saw this back in Chapter 3. We spent a lot of time talking about slope in Chapter 3. So the slope equation, remember, is when you take the change in your y over the change in your x. And what they did to get the point-slope form equation is that they rewrote this equation so that they got that fraction taken away. So they got the x2 minus x1 out. And really what they did is they multiplied like both sides of the equation here by that x2 minus x1 quantity. Now over here on the left, those cancel, and you have the y2 minus y1, which is what they wrote right here. And then over here on the right-hand side, you've got the slope, and then you've got, in parentheses, the x2 minus x1. And that's really what point-slope form is going to look like. Now, the only minor difference that you're going to see as I get into some examples today is I'm not going to write y2 or x2. I'm just going to write y and then minus y1 equals m times just an x minus x1. Now, the x2, the y2, or just my x and my y that I wrote down here, I'm not going to plug anything in for those. I'm going to leave them as just x and y. Just like when you guys were writing equations in Section 1 in slope-intercept form, you didn't put anything in for the y or for the x. So what you're going to plug into your equations is your slope, and the point that they give you is going to go in for the x1, y1. For example, I have slope of 1/2, so this is going to be your m value. And my point, 3, 4, this is going to be my x1, y1. So we're going to have y minus y1, which would be 4 for this example, equals, in for m, we're going to put 1/2, and then times x minus x1, which is a 3. That's what your equation is going to look like. Now, if they want you to write it in point-slope form, then you can leave it right here. You don't have to worry about rearranging it or solving for y or anything like that. Now, there might be problems in the future that ask us to do that, but for right now, I want you just to keep it in this form. Notice that the sign in front of your point values is going to be opposite of where they started. So my point that they gave me was 3, 4. Both of those were positive. When I put it into my equation, it almost looks like they became negative because I had y minus and x minus. So something to just kind of keep in mind is that when you put in the point to your equation, it's almost going to become the opposite sign in that formula or in that equation that you're leaving the answer with. Now, to graph a line that's in point-slope form, you're going to want to plot the point that they give you first, and then use your slope to get another point on that line. So, for example, for this first one, 3, 4 is your point, so you're going to go right 3 and then up 4. And then your slope is 1/2. So from that point 3, 4, we're going to go up 1 and right 2. Up 1 and right 2. And we've also talked about in the past that if you are running out of room for points, or if you're running into a situation where your y-intercept starts way up high on the graph, or like your point that you're dealing with maybe starts somewhere in a quadrant, and when you go to do your slope, you run out of room for the next point, you can always switch the directions of your slope to get other points on the line if you're running into that situation. So for example, because I went up 1, right 2, I could go down 1, left 2 instead. Then you just need to connect your line, draw your dots, or draw that line through those points there. Make sure that your line goes beyond those points though. You've got arrows on either side. On the bottom of this page, there are 2 practice problems. And I want you guys to go ahead and take a minute here and try to do both of these practice problems. And then when you have them written out, the equations, and you've got it graphed, go ahead and resume watching the video. So for this first one, remember your slope would be your m, and your point I would just label x1, y1. And so for this first equation, I did y minus 3 equals 2/3 goes in for m, and then it's x minus a negative 1. Now the only thing that I would expect to see you guys do is when you have a double sign like this, where it says x minus negative, I want that to switch so that it says x plus 1. We want you to clean that up. Okay, people are going to expect you to start being able to do that. They're not going to want to see double signs, and that would be the same if it was like a plus negative. They're going to want you to write that as just minus. So if you can clean up the signs a little bit, make sure that you're doing that. So this would be your equation. Now to graph this one, you're going to start at -1, 3, so you're going to go left 1, up 3. And then you're going to go for your slope up 2, right 3. Or you could go down 2, left 3. Now for the second practice problem, to write your equation, it should have said y minus 1 equals -5/6 times x minus 7. When you start this one, you want to go over 7 to the right and up 1 to get your first point. Now on your guys' note packet there, if you try to use your slope and go -5/6, you can go down 5, but you run out of room when you try to go right 6. So this would be that prime example where you maybe want to switch the order of your slope so that your other point will fit. So instead of going down 5, right 6, I'm going to go up 5, left 6. All right, this next example, they are still wanting us to write an equation in point slope form, but this time they're not necessarily giving us a point and the slope. This time they're giving us 2 points. So in order to do a problem like this where you're only given coordinates that are on the line, you're going to have to do a little bit more work because you got to find the slope, or you can put it into the equation. So, for example, I have this 4, 9, and 2, 3. Now what they're doing here is they're putting it into our slope equation. Remember that equation from last chapter looks like this. Okay, so they are doing 9 minus 3 on the top, and then 4 minus 2 on the bottom. So 9 minus 3 would be 6, and 4 minus 2 would be 2. 6 divided by 2 would be 3. So this is going to be your m value. M is 3. Then what you need to do is choose one of the points that they gave you from up above to put in your equation. And it doesn't matter which one you pick. So let's say you pick 4, 9. Now that you've got your slope, which is that 3, and you've got your coordinate here, 4, 9, we should be able to plug it into our point slope equation. So remember, this would be your x1, y1. So we do y minus the 9 equals 3 goes in for slope, and then x minus 4. And that would be your equation. Now, if you had chosen the other point, so let's say instead you wanted to use the point 2, 3. Then what your equation would look like is y minus 3 equals, still using this 3 for the slope, and then x minus 2. Either one of these equations would be acceptable. And both of them would represent the line. Now, they might look different right now, but if I were to rearrange these equations and write them in slope-intercept form, they would actually end up being the exact same equation. So that's why both of those answers would be acceptable, and that's why it doesn't matter what point that you pick. So I want you guys to try to do the practice problem underneath here. So step 1 would be to find your slope. So I did 2 minus 3 all over 4 minus negative 1. And so I got negative 1 over 5. So that's going to be my m value. Then I need to pick a point. So I'm just going to pick 4, 2. And then I'm going to write my equation. So it'd be y minus 2 equals negative 1/5 times x minus 4. Okay? Or, if you had picked the other point, negative 1, 3, because some of you out there might have done that, you might not have picked 4, 2, that equation would have said y minus 3 equals negative 1/5 times x plus 1. Again, because it would have been x minus a negative 1, but I would have wanted to see you clean that up and write plus 1 instead. Now, this next example is going to give us something that's in point-slope form, but they want you to rewrite it so that it's in slope-intercept form. So they want you to change it so that it's in that y equals mx plus b. Basically, what you're doing on a problem like this one is you're solving for the y. You're trying to get y by itself. The first thing that you're going to want to do is get rid of those parentheses. So in order to do that, you're going to need to distribute. So I'm going to take 2 times x and 2 times the 1. So this would say y minus 3 equals 2x plus 2. Then I need to get that negative 3 over to the other side. So I'm going to add 3, but when you add it over here on the other side of the equation, you can only add it to the 2. You can't add it to 2x because 3 doesn't have an x. And we would have y equals, we bring down the 2x, and then 2 plus 3 would be 5. And there would be your equation in slope-intercept form instead of point-slope form. So I want you to take a minute here and do this practice problem. So I started this one the same way. I distribute the 3 first. So I have y plus 5 equals 3x minus 12. Then I'm going to subtract 5. So I have y equals 3x, and then negative 12 minus 5 would be negative 17. This next example is showing you how we can take what we've been doing by writing equations in point-slope form and then maybe possibly having to rearrange it in slope-intercept form. But instead of just giving you coordinates or like points that come from a line somewhere, they're giving us points that represent a situation. So for this example, they're talking about years and the number of people or the number of girls that went out for the cross-country team. So in 2014, the cross-country team had 28 girls, and in 2015, the cross-country team had 32 girls. If the team grows at the same rate, how many girls would be on the team in the year 2020? So the points were 2014, 28, and 2015, 32. That's just the year and the number of girls that were signed out at the time. Now, in order for me to write this equation in point-slope form, I had to find slope first. So you can see how they set up 32 minus 28 all over that 2015 minus 2014. So 32 minus 28 would be 4, and there was 1 year on the bottom, so 4 over 1 just reduces to 4. So that's going to be your slope. Then you had to pick a point, just like we would have done before with the coordinates. This time it's just bigger numbers or different looking numbers. It's not necessarily just like 3, 2, or something like that. So I picked the point 2014, 28. You could have picked the other point 2015, 32 if you wanted. Then I plugged it into my point slope form just like we've been doing before. So your 4 goes in for M, 2014 would be your X1, 28 would be your Y1. So it's Y minus 28 equals 4 times X minus 2014. Then what they did is they took the equation in point slope form and they rewrote it in slope intercept form. So they started by distributing the 4. So that's how they got this 4x minus 8,056. And then they add that 28 over, just like we were doing on the last couple of examples, to get this equation. Y equals 4x minus 8,028. So that's the equation to represent this situation. Now they did ask us to figure out how many people would be on the team in the year 2020. So the year are represented by your x values. So we put 2020 in for x. So 4 times 2020 minus that 8,028, and we got 52. So if this cross-country team continued to grow at this rate over the next couple of years, then by the year 2020 came around, they should have had 52 girls on the team. So using that same method, I want you guys to read through this practice problem about Lamar's population, and then I want you to write the equation, start it out in point slope form, rewrite it in slope intercept form, and then use your equation to make a prediction about what the population would be in the future. So to write your coordinates, again, you're going to want the year to be the x values and the population to be your y values. So to start by finding slope, I took that 9,830 and I subtracted 9,241 all over 2010 minus 2,000. So that gave me 589 over 10, which I just simplified to 58.9. Then I picked the point 9,241. That's just the point that I decided to pick, and I used the 58.9 as my slope. So this is my x1, y1. So I wrote y minus 9,241 equals 58.9 times x minus 2,000. Now that would be point slope form, but they may want you to rewrite this in slope intercept form just so that we can use it as an equation to predict something that's going to come in the future. So I start by distributing. So it says 58.9x, and then I got minus 117,800. Then I would have added the 9,241 over. So I got y equals 58.9 x minus 108,559. So that's my equation that I could use to represent this population growth. Then they do ask what would be the population if it continued to grow in the year 2017. So to do that, you're going to want to put 2017 in for x. And when I did that, I got 10,242.3, which if you're talking about people here, we'd probably just want to round it to just 10,242, and we would say people. Okay, this next example is giving us the point slope equation, and what they want us to do is pull the slope and pull the point from the line. So if I wanted to graph this, I would maybe want those two pieces of information so that I could graph the line. Remember that your slope is always the number that's kind of sitting in front of the parentheses. So for this one, that would be the 2. Your point, remember that the x1 comes after the x and the y1 comes after the y. And it's always starting with a minus sign. So think of the opposite sign here. So I know that this one says x plus 1. But remember that means that it really started as x minus a negative 1 in order for it to become plus 1. So my point is actually going to be negative 1 and then positive 3. The thing that I always just tell students there is whatever sign you see in the equation, you need to pull the opposite sign out from the equation. So pull out a negative 1 and pull out a positive 3. So I want you guys to do that same thing with this example. So for this one, you should have pulled your slope as a negative 1/2. And for your point, I would have pulled a positive 3 and a negative 1. The last example we have here is they're giving us an equation in point slope form and they want us to rewrite it in standard form. Standard form was another way that we talked about writing lines back in chapter 3. This is when you have like your x and your y on the left hand side and then equals your c, which would just be the number in the equation. So we're getting the variables over to the left side and our plain numbers over onto the right side. What they did first here is they took that negative 3 and they multiplied it into the x and to that plus 5. So we've got y plus 2 equals, now it says negative 3x minus 15. Then what they did is they added 3x over to the other side. So now it says 3x plus y plus 2. So I've got my x and my y over here on the left, and that's where I want to keep them because I want to get it into this form. But I need to move this 2 over to the other side. So I subtract 2. And that's how I got 3x plus y equals negative 17. So this equation would be in standard form. The only thing that you maybe want to just kind of watch out for is when you're looking at the standard form equation, you want to make sure that your A, your B, and your C, so the numbers, that they don't have anything in common, like you couldn't reduce them at all. And you always want the first one to be positive. So if 3x had happened to be negative here, then I would need to switch the signs. So like if this had started out like negative 3x minus y equals 17, I would need to pull out the negative, or basically switch all the signs here, and have it say 3x plus y equals negative 17, which is what I had. So you just want to make sure that that beginning term is positive. So if you take a look at this example, if we follow the same process, we start by distributing the 4. We'd have y minus 6 equals 4x minus 4. I'm going to subtract 4x. That way I get it over onto the left-hand side. So now it says minus 4x minus 6. Oh, I forgot the y. So plus y, then minus 6 equals negative 4. So I've got my x and my y on the left. Now I want to move 6 over by adding it to this side. So I have negative 4x plus y equals 2. The only thing that I see that's the problem is this negative sign in the front. So I'm going to switch all the signs so that that becomes a positive 4x. And then it would say minus y equals negative 2. You just want to make sure that the numbers that you're dealing with don't have anything in common, like you couldn't reduce it by anything, or if that first one is negative, that you're pulling the negative out changing the sign of all those terms so that it becomes positive.